First we go to the body page and we bring on a box node, set its dimensions to 1 in X, Y and Z, set the TY to 0.5, put it on the ground. Then we go back to the brain page, bring on an output node, type in TZ into the channel, set the range from 0 to 10, and then we can give it a value of about 4.8. Alt F to see where our agent's going. Now, we're going to do terrain adaptation, so for that we need some terrain. File, load terrain. There's our terrain. And I just want to adjust the lights a little so that our shadow looks better. Select the key light, transform, that's better. Come back to our brain. And let's add an RY so that we can get our agent to go around in circles so we don't lose it. About 30 degrees ought to do. Right, well it's obviously not adapting to the terrain. So we bring on an input node and we type in ground into the source. This is going to give the value of the ground relative to the agent. Let's give that a range of -10 to 10. We'll need 2 fuzz nodes. One of them is high and the other is low. So now we need to define what high is for the ground, like this. Let's set that to about 4. From 0 to 4 is high. We can arrow up to get to the other one. And -4 to 0 is low. Let's make those linear. And if the ground is high relative to the agent, we want the agent to go up. And if the ground is low relative to the agent, we want the agent to go down. We can plug those into an output node. And we'll put TY in there. Give it a range of -100 to 100. So obviously up should be 100 and down should be -100. And let's see what that gives us. Oh, something wrong. Well, it's either going up or down. It can't stay on the same level. We're missing something. So we need to put in another defuzz node, and we'll call this one 0. This is what we want it to do when it's not going up or down. And since we've got nothing driving that value, let's make it an else. So it will be true, it will be asserted to the degree that the others are not. And we can see how that works. Like this, that's better. Now our agent is following the terrain. But we'd also like it to stay on the same angle as the terrain. So let's get another input node. This time we're going to type in ground.dz. And ground.dz represents the slope of the ground in respect to the z-axis of the agent. Well, the z-axis of the agent is just the direction that the agent is facing. So this means that this will tell the agent whether he's going uphill or downhill, whether the ground is rising or falling. So let's bring on 2 defuzz nodes, and we'll call them rising and interesting. We'll call that one rising and falling. And when our agent is rising, we want it to tilt want it to tilt forward. And this time we want Rx, which is going to rotate the agent about its x-axis. We'll give that a range of minus 200 to 200. Now, tilting back is a negative rotation. Tilting forward is a positive rotation. And we haven't said what rising and falling are. Well, rising goes from 0 to 1. And falling will go from minus 1 to 0. And we can make those linear too. Let's try that. Oops, again we forgot to put in an extra node. And it's 0, and we'll make it an else. That's better. Right, so it's rotating to adjust to the terrain as far as its x-axis is concerned, but what about sideways according to its z-axis? Well, all we have to do is copy and paste this and make a couple of changes. We want that to be ground.dx, and we want this to be z. Now we want it to tilt right and tilt left, and this now doesn't mean rising, this means that it's high on the left, and this one now means that it's high on the right. Okay, and tilt right should be 200 degrees, and tilt left should be minus 200 degrees. Now it will adjust its attitude in both the x and z rotations. Great, but what if we want to be able to control the rotation about x and z axes? Let's add some AND nodes in here to enable us to do that. So we'll just chuck in some AND nodes. Like that. Disconnect our fuzzes from our defuzzes. And connect them via the AND nodes. Now that should behave exactly as before, and indeed it does. But now what we can do is bring on an input node and plug it into these ANDs. So they can only be true now when this input node is true. If the input node is off, we don't get any adjustment to the terrain. If we switch it on, we do. Now we can turn this whole part of the brain here into a macro. Let's just select it and go Alt-G. Now it's all been condensed into a macro. If we hover the mouse over that macro, we can hit the Enter key to go inside it. And now, if we click on Input and go Alt-X for external, that input node will now be externally available in the macro. Let's backspace out of the macro to see the effect of that. So backspace takes us back out of the macro. And there we see our input node. We'll click on the macro so that we can give it a better name, terrain. It's our terrain adaptation module. And we can adjust the angle varying behavior with this slider here.